Hello, everyone. Okay, any questions before we start? All right. So today we're gonna keep talking about logic. So last time we talked about logical equivalence. Logical equivalence means basically if you have two compound statement, it means compound statement means statement obtained by combining other statements by the or the and or negation or the implication. And we say that two statements are logically equivalent if they have the same truth table. It means, and if my memory is correct, we talked about this, that this is logically equivalent. It's like the distributivity property for number. Exactly, that's what this is. It's called the distributivity property, and P or R. So we're basically distributing P to Q, and then we're distributing P to R. Now, so today we're going to use this logical equivalence to talk about negation. Negation. Now, let us remember what negation is. We know very little about negation. So if you have a statement P, very simple statement, nothing really deep about it, of the form 2 is even, very simple statement. Then the negation is, it's not true that P is even, it means 2 is not even. So the negation is not. So negating, very simple statement, 2 is even, is 2 is not. And negation is, by definition, the statement that if the original is true, the negation has to be false. The original is false, the negation has to be true. One way to understand negation, at least simple, is the negation should tell you exactly when the original statement is false. That's really what the negation, it really tells you what the original statement is false. So today we're going to start negating more complex statements. It means compounded statement. And those will follow rule. So negating compounded statement means statement obtained by adding or and will really require very specific rule. And today we're going to see the first rule, De Morgan's law. Okay, De Morgan's law. De Morgan's law is going to tell me about if you have P or Q. P or Q. And you are negating that. What is the negation of P or Q? Remember, the negation should capture when the original statement is false. So the negation is true when the original is false. So it means it should capture when the original is false. Now, if we think about the P or Q, when the original is false, when P is false and Q is false. So this is not an explanation, but this tells me that P or Q is false. It means a negation is true when P is false, means non-P is true, and Q is false. All right, so we're going to use the truth table to verify that. So let us see if what I'm telling Q is correct. So this is my P, this is my Q. And so P can take two values, and this will take true, false, true, false. Now P or Q is true, 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 false in only one case. That's where it is false. So the negation of the whole thing, P or Q, so the negation of it is going to be false, 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 true. So the negation is true exactly in one scenario. The negation is true when P and Q are false. It means when both of them are false. So now if I take right here the negation of P and the negation of Q, and I find their truth table, what's going to happen? If P true, now P is false. It means it's going to be false. If P true, non-P is false. And you know there is an and. When there is an and, false and anything is false, period. When P is false, non-P is true, but Q here is true. It means non-Q is false. It's only in this scenario, non-P is true because P is false, non-P is true, and this is true. So those two have exactly the same truth table. So negating the or is actually the negation of P and the negation of Q. Very important to know how to negate statement. Now, by the same token, we have to know what's the negation of P and Q. And I guess you guys can figure this out now. What's the negation of P and Q? It means, let us think a little bit. When P and Q is false, because P and Q is false, the negation is false when P and Q is the negation is true when P and Q is false. But when is P and Q is false? P and Q is false if one of them is false. It means if either P is false or Q is false, or both of them. So the candidate would be or the negation of Q. Okay, so the negation of P and Q is the negation of P or the negation of Q. All right, and we can make the truth table, of course, and it should not be hard to make sure that this works using the truth table. So logically, we think it does, but this is logic can throw us out. So now the P and Q and the negation of P and Q, and finally non-P and non-Q. True, true, false, false. True, false, true, false. P and Q, we know P and Q is true here. Everywhere it's false. So the negation is false in here and it's true everywhere else. So P and Q is false when one of them is false. So the negation is true when one of them is false. So that's gonna give me the negation of P or Q, it's false in this case. And here, Q is false. Non-Q is true. Non-Q or anything, I don't really care. Right here, Q is false, but P is false. It means non-P is true. I don't care about the rest. It's true. Both are false, both are true. So that's really De Morgan's law. All right, so let us practice a little bit. De Morgan's law is absolutely crucial to know how to negate mathematical statement. So as I said, only easy statement is, even, is not. Those are the easy ones. Anything else, we have to follow the rules of logic. So let us get into the habit of really...
Professor,
I'm listening.
Can I see the bottom of that table?
Absolutely, you can. This one?
Yes, thank you.
Okay. Okay, shall I move on?
Yes, thank you.
All right, sure. So now we're going to practice this, all right? And the question is using De Morgan's law of logic. So I will keep it in front of you so you write the negation of each statement. So we're gonna use De Morgan's law to write the negation. So the first one, 2 is even and prime. So it means basically we're gonna write it so it will be very clear. So what does this mean? It means 2 is even, that's what it means, and that's our keyword here, 2 is prime. Okay, so now we're going to write the negation. Because it has to become, negating has to become a second nature to us. So here, that's my P, and that's my Q. Both are simple statements. So what's going to be the negation? So basically, I'm negating P and Q. Of course, you're not going to keep it like this. It means it's the negation of P or non-Q. And now we write this in English. So the negation is going to be 2 is even. Oh, sorry. The negation is going to be 2 is not even, or 2 is not odd and is not prime. All right. So let's see a little bit the truth value. Is my original statement true or false? Quickly. My original statement, is it true or false? You remember
True.
the chat? You can use it. It's absolutely true. This has to be false. If you negate and the negation is true, it means you're negating wrong. Absolutely. 2 is not even, or 2 is not prime. This is absolutely a false statement because both of them are false. All right. Okay, now 3 again. I give you like 30 seconds to negate this. So you go after the E word. 3 is even or prime. Okay, we read it. Always you have to make sure we read it mathematically carefully. It means 3 is even or 3 is prime. Okay, so we have to read it carefully first to understand. So this is my P, and this is my Q. And the statement is 3 is even or 3 is prime. That's absolutely a true statement because one of them is true. I don't care about that. If one is true, my statement is true. So the negation would be very quickly.
False.
Yeah, but what it is? We have to write in English.
Oh, 3 is not even.
Always in English. 3 is not even.
And 3 is not prime.
And. Crucial. And. Okay. So it takes a little bit of practice to make it, as I said, a second nature to us. Okay, second nature. All right, 2 more and then we proceed. 5 is neither even nor prime. First, let us remember what's neither. I've talked about it last time. Neither nor means what? Remember, what does neither nor mean?
Wouldn't that be like the and part?
Yeah, but and yes, you're right. So rewrite it for me in a more clear way. This sentence before we negate. Neither nor. I want you to rewrite it to be more clear. And then I'm going to write the negation. Anybody understand what my question is?
Not P and not Q.
Right. It means is not even and 5 is not prime. Because once we understand it correctly, negating will not be hard anymore. So this is, I'm negating this up to here and then up to here. All right, so what's going to be the negation? Negation of 5 is not even is, quickly.
Is even?
Yeah, the negation of the negation is the statement itself. It's not true that 5 is not even. It means 5 is even. Or 5 is not prime. 5 is prime. Okay, so 5 is not even. The negation, how could it be not even if it is even? How could not be prime if it is prime? Or 5 is prime. Now let us a little bit the truth of it. 5 is not even and 5 is not prime. This is a what? False or true? You guys are reluctant. This is a false or true statement. It's absolutely a false. 5 is not even. That's a false statement. 5 is not prime. That's a false statement. Both are false, so it's false. Now this has to be true. Or what I'm writing doesn't make sense. 5 is even, it is false, but there is an or. If one is true, the other is true. 5 is prime is true. At least it's not that I'm negating correctly, but at least give me an idea that I'm not goofing a lot. Okay, and now the last one. It's 3 different propositions basically. I will still have to negate it. Okay, I'll give you 2 minutes to, you have to basically break it apart and then negate it after you break it apart. Okay. So how are we going to write this? 15 divisible by 5 or 3 means 15 divisible by 5 or 15 divisible by 3, but means what? And 5, 15 not divisible by 6. Okay, so that's how we can write it, just break it apart. So it means that this is, we have really 3 statements. That's a P and a Q. And you can think of this as another one R. So this basically P or Q and R, right? And now we have to negate that. Okay, you can either negate it by looking at it, or you can really negate it slowly. So I keep this in front of you and I'll put it up here. So it's gonna be the negation. So negation. So we can negate it if you want formally, and then we negate it in English. So what's the negation? Right. I have this and that. So the negation is going to be the negation of P or Q or non-R. Right. Now let's move, let's zoom in a little bit more, Nick. So this is going to be, this is one piece, I leave it. Non-P or non-Q, it means non-P and non-Q. It's this or not R. So now we write it in English. Okay, so this is a verb, peer. Yeah, okay. So now let us negate it clearly. So it's going to be 15 divisible by 5. It means 15 not divisible by 5 and 15 not divisible by 3, or, oh, here it depends what I put R. If I put R, and Peter is right, if I put R 15 not divisible, then non-R it means or 15 is divisible by 6. Okay, so it depends what we put the R to be. All right, so the negation is going to be 15 not divisible by 5 and not divisible by 3, or 15 divisible by 6. Now let us a little bit talk about the truth of it. Is my original statement true or false? Is my original true or false? What do you think?
True.
True. Do you agree with your classmate? 15 is divisible by 5 or 3, that's a true statement. And not divisible by 6, that's of course a true statement. Both are true. And so my negation has to be, of course, false. 15 not divisible by 5 and not divisible by 3, that's false. But it doesn't matter, I still have to look at that because I have a or divisible by 6, so I had a false. 15 not divisible by 5 and not divisible by 3, that's a false statement. Or 15 divisible by 6, that's also a false statement. That's a false statement, all right? So that's how we negate. So we can, I mean, the main idea is to use De Morgan's law, but even if the expression is like tiny bit complicated, we can also break it by using De Morgan's law slowly. Right, now, we're gonna do a lot of negation today. One thing about negation now, I would like you to do the following. So negating inequalities. Okay. Suppose x is a non-number. So x is a number that's in my head. You don't have to worry about it. And I'm telling you, negate the following statement. Negate x. So x is something in my mind between 1 and 2. Okay? And I wanted to negate this statement. So how can this not be true? So negating, it means you're basically telling me how this cannot be true in all possible scenarios. All right, Nick is writing, the negation is x. Okay, Nick, I'm understanding that. Is this what you mean? Okay, I'm understanding that. Now, I don't know what this is logically, what do you mean? It's hard to understand it because this is telling me 1 is bigger than 2. So it tells me 1 bigger than x and x bigger than 2. It means basically 1 is bigger than 2. It doesn't really work, all right? Anybody else? I see x less than 1 or x bigger than 2. That makes sense. Anybody? So one of them is correct. Right. Let's do it logically. Let's do it in a very logical way. X between 1 and 2. We're going to do it, first logically. What does this mean? Let's see what does this mean. How do we understand this? I want the and the or. This can read x less than 2. What else? And, you see the and, x bigger than 1. Okay? So x less than 2, this reads x less than 2 and x bigger than 1. So now when we're going to negate it, how are we going to negate it? X bigger or equal to 2 or x less or equal to 1. That's the proper negation of the sentence. So x between 1 and 2, well, the negation is x bigger or equal to 2 or x less or equal to 1. And this statement, why it makes sense, this negation, because watch carefully. X bigger than between 1 and 2, it means this is 1 and 2. Means x in here. How can this be false? How can this be false? It's going to be false if x is here, less or equal to 1, or x is here, bigger or equal to 2. But the negation should totally capture how your statement is false. So how can the statement x between 1 and 2 is false if x is from here to here, less or equal to 1, or x is bigger or equal to 2, which is right there. Okay, so negating inequality is usually, once you see it, you understand it, but that's how we did. We have to break things up. We have to break things up, write them as ands and or, so we can be able to work with them. Okay. Now we're going to work with conditional statement. So now we know how to negate absolutely in or and in and you guys will have some practice problems for next time. And now we're going to work back to the conditional statement. And how do we negate a conditional statement? Okay, so let me remind you the truth table of the conditional statement. So negating conditional, the truth table is if P then Q. Okay, now let's see that's the truth table. P, Q, if P then Q. Okay, and when a conditional statement is false, Usually it's easy to know when it is false because it's false in only one scenario. When if P then Q is false, quickly. When is this false? Anybody? Remember, you guys have almost memorized this stuff. When if P then Q is false? If true, false. Yeah, it's false if hypothesis is true or the premise and the conclusion is false. So it's only false in this case. It's true everywhere else. Okay. Now, what's the negation of P and Q? The negation basically should capture, so we're going to see what the negation is. So I can like take another piece of paper here. Okay, so that's the negation of the conditional statement. So that's of P then Q. That's the negation of it. The negation should capture exactly when the statement is false. So if I go to the, so that's, I'm explaining it logically, I mean intuitively, and then we do the truth table to confirm. So that this is my P and my Q. So one more time, the P, if P then Q is true, true, false, false, true, false, true, false. So it's false right there. So if P then Q is false in one scenario, P true and Q false. So the negation should be true only in this case. And it should be false everywhere else. So if we think about it, when is the negation true? The negation is true if in the following scenario, when P is true and Q is false. And Q is false. It means non-Q is true. So the negation is true in one scenario when P true and the negation is false and non-Q. So this is what suggests that. Now let me verify it using the truth table. Let me just convince you, yes, they have the same truth value. So if I do P and non-Q, let's see what I get. In this scenario, P is true, and since it's an AND, P is true, I have to check Q. Q is true, non-Q is false, so that's a false. In this scenario, P is true, fine, there is an AND here. Q is false, it means non-Q is true, so that's a true statement. Now here, P is false, I'm done. The whole thing is false. Q is false, I'm done. The whole thing is false, okay? So negation of a conditional statement, if P then Q, is P and non-Q. Now, note something very important. The negation of a conditional statement is not a conditional statement. So let's write this down. The negation, I'll write it because it's important. Negation of a conditional statement is not conditional. It's an AND statement. It's not a conditional statement. It's an AND statement. It is an AND statement. Okay. So how can it has to capture how the statement if P then Q is false. So the statement if P then Q is false when P true and Q false. It means non-Q is true. So the negation of that is P and non-Q. So it's not an if statement, it's actually an AND statement. All right, so we're going to practice those a little bit. Let's get going. So negate each of the statement below. So we start with A and we are going to negate the statement. If 2 is prime, then 2 is odd. So this is if, then. If, then. So now we have if, then. So this is my premise here, or my hypothesis, and this is my Q. So now I'm negating if P, then Q, the simple possible scenario. And what's the negation? Quickly. Okay. The negation is P and non-Q, because it has to capture why this statement is false. So if 2 is prime, then 2 is odd. What's the negation? Quickly. I mean, quickly, who would like to say it? No, absolutely not. But I see on chat is not correct. Immediately not correct because watch carefully what I said. The negation of a conditional statement is not a conditional statement. It means it's not if then. The negation is in and statement. So the negation of that is P, whatever P is, and non-Q. So what is the negation here? If 2 is prime, then 2 is odd. The negation is 2 is prime, but 2, but or and 2 is not odd. Okay. Now, and it's important because our natural tendency is basically to negate NF by NF. And here the idea, no, it's not. So if 2 is prime, then 2 is odd. Now we know that this is a false statement because P is prime, so this is true, and the conclusion is false. So this is really false. So the negation is 2 is prime, but 2 is not odd, which is a true statement because 2 is prime, that's correct. 2 is not odd is correct as well. Okay, now we move on. As I said, we're going to do negation B. If P is a square, then P is a rectangle. Now we discussed this last time and we decided this is true whether you know what P is or you don't. Because if P is a quadrilateral, that's what I'm telling you. So if P is a square, then we know that it's a rectangle. If P is not a square, the statement is true because my premise is false. So this is always true. But now I want the negation of that. And when you negate it, you start making sense. So how would you negate if P is a square? So that's in if, then this is my P right there, my first statement. And this is, so that's my premise if you want, and this is my conclusion. So what is the negation? Exactly, P is a square and P is not a rectangle. I already know it starts clicking, it starts really making sense. Because how can this statement be false? We know it's not. The only way it can be false if P is a square and P is not a rectangle, but this is really cannot happen. So the negation is P is a square and P is not a rectangle. Okay, so the way we negate if-then statement is not an if-then, is an if-then statement is false when hypothesis is true and conclusion is false. That's how we negate. We're capturing how is it possible for my statement to be false. Okay. Now we're gonna talk about two other things concerning the if P then Q ideas. Okay, can I move on? Any questions before we move on? All right, now we're going to talk about the contrapositive of a conditional statement. So I put this down here and we defined it. So we have a statement if P then Q, the contrapositive of if P then Q, contrapositive. So contrapositive. So what's the contrapositive? First definition, and then we work with them. What's the contrapositive of a conditional statement? So if you have a conditional statement, if P then Q, that's the definition. This contrapositive is if non-Q, then non-P. So that's the definition. It has nothing to do with the negation. We're not negating. So if P then Q, that's the contrapositive. So we're going to write the contrapositive of statement and then talk about them. So write the contrapositive of the following. All right, are you guys writing it down? So this is my P, and this is my P, the proposition, and this is my Q. So what is, if P is not a rectangle, is not a rectangle, so that's the contrapositive. It's not a rectangle, then P is not a square. Okay. All right, so non-Q, if non-Q, then non-P. Okay, so be very careful. So this is the this is if P then Q. The contrapositive, if non-Q, then non-P. So if P is not a rectangle, then P is not a square. So it's not this and it's not this square. Now let us check the truth value of both of them. If is the original one, we decided it is true because we've talked about it last time. If you have any quadrilateral, if it's a square, it is definitely a rectangle. Now, what about my contrapositive? Is it a true statement? Is my contrapositive true? What do you think? So if I give you any quadrilateral, if P is not a rectangle, then P is not a square. Is this a true statement or a false statement? You can either unmute and talk or write down. What do you think? It is true, absolutely true, because if it's not a rectangle, it's not a square, because if it were a square, it would have been a rectangle. So it's definitely a true statement. Okay, now part 2. I want you to negate the following, no, sorry, find the contrapositive. If John Smith is born in the US, then John Smith is a US citizen. Question number 1, is this a true statement? Is this a true statement? Whether you know John Smith or you don't know John Smith. What do you think? Is it true?
Yes.
Yes, because if John Smith is actually born in the US, so immediately he's a US citizen. If John Smith is not born in the US, my premise is false, so I don't really care whether he's US citizen or not. So whether we know John or we don't, this is an absolutely true statement. And now we're going to write the contrapositive. Right? So now the contrapositive, this is my premise, and this is my conclusion. So this is my P, and this is my Q, or R, or L. You can call them anything you want. So the contrapositive will become non-Q. If non-Q, then non-P. So non-Q, it means if John is not a US citizen, Smith is not a US citizen, then John was not born in this country. That's at least we know in the US side. Okay, which is again is a true statement. If he is not a US citizen, at least I know that he was not born, because if he were born, then he would have been a US citizen. Okay, so which is again a true statement. Okay. So now, one thing about a statement and its contrapositive. Important. An if statement is logically equivalent to its contrapositive. Okay, so I probably should write this on another piece of paper. Okay, so here, sorry, every statement is logically equivalent to its contrapositive. It means every value of P and Q that make the original statement true will make that true. And whenever this is false, this is false. Okay, so we can have a truth table for that, and actually we can even think about it also. And the example kind of suggests that's what's going to happen. So the truth table is simple. That's P and Q. And actually I'm going to put non-Q and non-P, so to totally fill it out. And then that's what the situation is. P could be true, true, false, false, true, false, true, false. Non-Q, I put non-Q, I don't know why. That's going to be false, true, false, true. And non-P is going to be true, sorry, false, false, true, true. And then we're going to capture both of the other two. If P, then Q. And non-Q, then non-P. This line doesn't belong. So let's do that. P then Q, we know by heart. It's only false here, true everywhere else. That's P then Q. Now, if non-Q, then non-P, let's see what it is. Okay, non-Q. Non-Q is false. It means I don't care about the rest, it's true. Non-Q is true, I have to worry about that. If non-Q is true, non-P is false. That's the only situation where an implication could be false. Non-Q is false, the rest has to be true. Non-Q is true, and non-P, that would be true. So they have absolutely the same truth table. So basically, it make, I mean, the contrapositive is logically equivalent to the initial statement actually make sense, because if you go back to the example we have, okay, if P is a square, then P is a rectangle. It means that if it's not a rectangle, then P is not a square. That's really what we are saying, and that's really make it very, very logical. So if this is true, then of course, if this doesn't hold, this one will not hold as well, because if the original statement is true. Okay, so now, so very important ideas, very crucial for understanding basically the logic of mathematics. Now there is another thing we're going to talk about. So today is a lot of definition, which are, you know, the ABCs of the course. So we negated the or and the and. We negated the if-then statement. Now we talk about the idea of contrapositive. Now there is still the idea of the converse that also come up with that sometimes. So what's the converse of a statement? Okay. Right. Please, if I'm going fast, stop me and tell me as you did before. All right. So what's the converse of a conditional statement? Right. The converse of if P then Q is if Q then P. Okay, so the converse of if P then Q is nothing more than if Q then P. Okay, so let us write the converse of a statement. So we basically, the hypothesis becomes the conclusion, and the conclusion becomes the hypothesis. That's the converse of a statement. So let us write the converse of the following. If P is a square, then P is a rectangle, which is using. Yes.
Can you go up? Thank you.
Thank you very much. Okay. So now let us take the same example. Let's write the converse of. If P is a square, then P is a rectangle. Now we know that this is true, of course. Now what's the converse? The converse is very easy. Just flipping things around. You're not negating. You're not really doing much. So if P, then Q. So the converse will become if P is a rectangle, then P is a square. Okay, so if P is a rectangle, just switch things around. If P is a rectangle, then P is a square. And let's see, this is a true statement? No, that's a false statement. Okay. Now, find the converse of the second. If Norma Elias is born in the US, Norma Elias is myself, which is false, as you guys know that. Then Norma Elias is a US citizen. This is true because I am a US citizen. So this is for us is a true statement. Is it a true statement? Yeah, because the hypothesis is false, so this is absolutely a true statement. Now I want you to write the converse of this statement, get going. So if, then, I always emphasize this is in if, then. So this is basically my hypothesis and that's my premise. So what's going to be the converse of that? Okay, I would like to say it in words. And then tell me if it's true or false. So if Norma Elias is a US citizen, then Norma Elias is born in this country. Okay, you think this is a true or a false statement? Since you know that I told you what it is. Is it true or false? Converse is false because the premise is true. Well, the conclusion definitely false. That's a false statement. All right, so the converse is easy. Is you just flip things around. There is nothing really hard about it. So in this case, that's a true false. That's a true false. Now, who can give me an example where a statement, very simple example, nothing really deep, a statement and its converse are both true. So if a statement is true, the converse doesn't have to be true. That's really very clear in those examples. Who can think of an example where a statement is true and Chris is asking me, why is the original statement true? This one, Chris? Why this one is true? If Norma Elias is born in the US, that's false. I was not born in the US. Okay, and whenever the premise is false, the statement is true. That's why the original statement is true. So the original statement is true because my premise is false. I was not born in the US. That's why it's a true statement. So we don't care about the conclusion. All right? Make sense?
So you're just, yes.
Yeah, all right. Now, who can give me an example of a statement which is true and its converse to be true? Anything, doesn't have to be deep, you know, use to, even, odd, something simple. Okay, anybody? All right, Simon wrote, if 2 is even, then 4 is even. All right, if let's write his statement down, make sure it makes sense to everybody. So the statement is, if 2 is even, then 4 is even. Okay, so that's the statement. So the converse, so is this true? 2 is even, 4 is even, absolutely true. The converse that if 4 is even, which is true, then 2 is even. That's also a true statement. So a statement could be even, the converse, sorry, the statement could be true, the converse false. The statement could be true, the converse could be true. So there is not really any kind of relation between the statement and its converse in terms of their truth value. They could be either one. All right, so let us now summarize by one example to make sure we get all of them. So this is my example it's written in front of you. So if 30 is divisible by 5 and 10, then 30 is divisible by 50. And my question to you is, I want you to write the negation of the statement. Remember, that's in if then. I want you to write the contrapositive, and I want you to write the converse. Okay, so please get going. You can, as we did, like break up the sentence so you can see the parts and then start the decomposition. Oops. Okay, so we're going to negate the statement. So that's in if, then. If, then. And this is actually a composition. You can think of this as P and Q if you want. And we can think of this as NR. And we are negating that. Who's ready for the negation? Okay, you say it in word and I write it down. Anyone? Anybody ready? How to negate this? Don't let me pick. I want you guys to tell me.
So 30 is not divisible by 5 and 10.
No, absolutely not. What's the negation of the conditional? Go back to your notes. Let's go back to the notes that all of you have to study very well. What's the negation of in general? What's the negation in general? It's P and not Q. Because a statement is false when the premise is false and the conclusion, when the premise is true and the conclusion is false, or you can memorize it. So what's the premise here? That's the premise. And that's the conclusion. So the negation is going to be P and Q, that's the premise, and non-R. Okay? That is going, is that not or, not or, not or. Okay, that's the negation. P and Q, it means the premise and not R. So let us write down. So the negation is going to be 30 divisible by 5 and 10. So I'm not changing my premise. So the premise is satisfied, but not R. But 30 is not divisible by 50. So that's P and Q and not R. Okay, so that's how we negate. So the negation is premise and not conclusion, whatever the premise are. So the premise is what comes before the then. It's what's between the if and the then. So if 30 is divisible by 6 and 10, then how can this be false? So what's the negation? It means 30 is divisible, but 30 is not divisible by 50. And now let us analyze. Is the original statement true? Is the original statement true or false? What do you think? False? Do you agree with Tim? Do you agree with Tim? 30 divisible by 5 or 6, that's a true statement. 30 divisible by 50, of course, that's a false statement. So hypothesis true, conclusion false, that's a false statement. Now, is this true? Of course, because the hypothesis is true. We know that the hypothesis is true. 30 is not divisible by 50, that's false. So this is definitely, 30 is not divisible by 50, that's the true statement. So that's a true statement, right? So again, how do you negate if then? It's the hypothesis, whatever it is, and non-conclusion. It's not an if then, you don't touch the hypothesis, P and Q and non-R. Now I want you to do the contrapositive. So remember the definition of it. The definition is it's non-R. If non-R, then non-hypothesis. But this time my hypothesis ended up to be a compounded piece. Okay, if 30, now Michael is telling me if 30 is not divisible by 50, that's correct so far. By 50, correct then. Okay, then non-P and Q. But what's the negation of non-P and Q? So this is means non-R. I'm going to zoom in. How do we negate 30 divisible by 5 and 10? De Morgan's law get into the picture. So the way we negate that is that's not P or not R. So if 30 is not divisible by 50, then 30 is not divisible by 6. By 5, sorry, or not divisible by 10. Okay, so we zoom on as much as we can using the exact rule. Okay, so if 30 is not divisible by 50, then 30 is not divisible by 5 or not divisible by 10. And let us, we know this should be false, but let us really kind of break it up why it is false. Is the premise true or false? The premise is what comes after 50. Is this true or false? This piece. $30 not divisible by 50. That's a true statement. Very good. So now this is. What about the conclusion? Is it true or false? 30 not divisible by 5. No, that's false because 30 is. But there is an or. I have to look at the other piece. Not divisible by 10, that's false because 30 is. So this is also, this is false. True, false will give me absolutely a false statement, which we should have because the contrapositive and the statement are logically equivalent. If one is true, the other one is true. All right, finally, the converse. The converse is usually not problematic at all because you just switch things around. So I have P and Q. If P and Q, then R. So the converse is going to be the following. So the converse is going to be if R, then P and Q. So there is nothing really here, that's the converse. Okay. And the converse could be true. Yes, the contrapositive is false. It has to be false. If the original statement is false, the contrapositive has to be false. And if by any chance the contrapositive is true, it means we are doing a logical statement. We are doing something wrong. Okay? Because just think about it. If P is a square, then P is a rectangle. So if P is not a rectangle, this is true, and P not a rectangle, definitely P has not to be a square because if it's square, it has to be a rectangle. So they are really have the same truth value. Finally, the converse of this, that's a simple. So who would like to write the converse for us? If 30 is divisible by 50, so it's if 30 is divisible by 50, then, so we just, 30 is divisible by 5, and by 10. Okay, so the converse could be true, the converse could be false. It has nothing to do with the original statement. We can have both statements. Okay, so breaking up statement as we're doing is actually extremely helpful to be able to negate, to find the contrapositive, to find the converse is easy, but breaking up statement is absolutely crucial, and knowing the rule. You have to know the rule very, very well. Right. The last idea we talk about today, of course, related to that, is what we call a biconditional statement. So biconditional statement is the following. Okay. Biconditional statement. Okay. Suppose P and Q are two statements. Now, sometimes in math, you hear P if and only if Q. This is called a biconditional statement. And it's denoted by, two arrows. So what does it mean to say that P if and only if Q is true? P if and only if Q is true if two things are true. If P then Q is true, and its converse, Q then P is true. Because we know that if a statement is true, the converse doesn't have to be true. Okay, so now we say that a statement P if and only if Q, so if you hear P and only if true, it means that I'm telling you that if P is true, if P then Q is true, and if Q then P is false, is true. So both of them, the statement and its converse has to be true. So mathematically, P if and only if means P if P then Q, and if Q then P. So that's how it means to be true. Now it's truth table. Now it's truth table, how it is the truth table. Let us think a little bit. What's the truth table? If P and Q are true, both are true, then this will be true, and this will be true, then this would be true. Suppose P true and Q false. If P is true, Q false, this will be false, then if and only if will be false. Now, if P is false, that's true. But if P is false and Q is true, so this true and false, this will have to be a false statement. If both false, what happened here? P is false, this is true. Q false, this is true. It is true. So the truth table of P if and only if Q is the following: is true if both are true and both are false, is false otherwise. So P if and only if Q is true if both are true or both are false, is false if one is true, one is false. But the best way to understand the biconditional statement is this way. P if and only if is true if P then Q is true and Q then P is true. Okay, and biconditional statement occur a lot in math. So we cannot state a lot of theorem, but since most of you have been exposed somehow to linear algebra, suppose in linear algebra they tell me the following. They take a matrix A, B, C, D, a simple matrix 2 by 2, and they tell you that A, B, C, D is invertible. It means you can multiply it by something to give you the identity. It's invertible if and only if. So watch carefully. When we teach linear algebra, we don't make a big deal out of it. But now we should be able to understand it. If and only if the determinant is different from 0. Okay, so that's a typical statement for linear algebra. What does this mean to us? So I tell you that this is a true statement. Okay, what does it mean to you? It means two things to you. It means the following. If I give you a matrix, and I tell you it's invertible, suppose this is invertible, then immediately, what does it mean invertible? It means there is something you multiply it by to get the identity, then immediately you can deduce this. ABC different from 0. So I give you a matrix, okay, and I tell you it's invertible, then you tell me immediately, okay, it means this is non-zero. And also it tells you the following. If I start with a matrix and you compute this and you get non-zero, then immediately you can deduce that it is invertible, meaning you can multiply it by something to get the identity. So that's if and only if statement. It means if one is true, if this is true, then this will be true. Not only that, this is true, this will have to be true. So it's telling a lot about the statement. So that's the biconditional statement. So let us a little bit summarize all what what we've seen today, because we will always refer to those ideas. We will always refer. We will always negate. We always. So let us a bit of a summary. Okay, summary. So the most important matter. First, De Morgan's law. De Morgan's law tells me that the negation of P and Q is the negation of P or the negation of Q. So that's De Morgan's law. And the negation of P or Q is the negation of P and the negation of Q. So that's De Morgan's law. Okay. And then we negated if-then statement. The negation of that is P and non-Q. And what I emphasized here basically is that try to remind you that the negation of if P then Q is not if statement, it's an and statement. Okay, so that's negation of conditional statement. And then we've talked about contrapositive. So the contrapositive of if P then Q is if non-Q then non-P. And the important things about the contrapositive, it means if a statement is true, its contrapositive is true as well, and the other way around. So they are logically equivalent, And finally, we talked about the converse. That's easy. The converse of a statement is if Q then P. And finally, biconditional. The biconditional statement, P if and only if Q. This is basically mean if P then Q. That's the best way I like you to memorize it. And if Q then P. So this is true if P then Q is true and Q then P is true. Okay, so these are the main idea we've talked about. And for next time, for Monday, I will put on Blackboard, so I meant on Brightspace, I'm gonna put a practice problems where you have to practice all those ideas. Okay, it's not homework. I will include some in the homework, but for now, I just want you to practice those very well. I have like a summary of what we did, and I have some practice where you have to negate, find the contrapositive, find the negation, till it becomes, as I said, I want this to become almost a second nature to all of us. Okay. Next time I will move. I mean, this is chapter 3 in the book. Next time I'm trying to follow the book to make it easier on you. I'm planning to move to counting. So we're gonna start counting next time. So combinatorics, basically, combination, permutation, and so on and so forth. Okay. All right. So that's it for today. Do you guys have any questions? Did you have any problem with the homework? I didn't get any questions, so I assume you didn't. All right. The lecture is done for today. If you have any questions, please, you can stay and ask me questions. Grace, did you get what you want? Yes, you had a question about the homework. What is it, Logan? Sorry. You can unmute and talk, it's easier.
I got it.
Oh, you don't have a mic. Oh, I don't have it in front of me. Which number? Can you write the number? See if I can pull it. My answer was very lengthy. It didn't seem right for whatever reason. Okay. Number 8, it was 3 circles when diagram was middle piece missing. Ah. I mean, I will have definitely to look at what you did and see. So I imagine it's this one. Okay, that's the one, right? And I forgot to put that. I said this is A, B, and C. Okay, so looking at it, so one way you can see it. So I don't know what you did. You can pick it piece by piece. So for example, you can do this piece first, and this seems to be the A minus the B union C. That's one piece. And you add to it this piece. So there is a really symmetry. So that's one possibility. I'm sure you guys will come up with other, probably nicer one. B minus A union C union C minus A union B. So that's one scenario we can do. Was it like that? Logan, are you with me? Yeah, you had two different answers. Okay, I have to look at what you had and I will make sure to correct it, whatever it is. All right, so this is one way you can do it. I'm sure there are other ways, probably nicer than this one. I have to see what you guys have done with it. So I will grade it hopefully over the weekend and I will get back to you. I mean, I will have the feedback to explain it to you. All right, any other questions? Okay, I see you guys Monday, so please make sure you do the practice problem. And bye for now. Anything else? Anybody else?